So during my interactions with the customer, people always ask me they say the VMs in their cluster usually suffer because of the periodic resource surge that happens in the other VMs in the cluster. This is actually resulting in application performance drop. And there are other set of customers, they tend to reserve more capacity so that they can accommodate the peak workload, even though the overall average loads are much lower. This is again resulting in inefficient resource usage. Though these appear like two different problems, if you look closely, the underlying cause is the same. It's the occasional resource contention that's happening in the clusters. So what is the right way to address this resource contention? Either you can react to it, you can react to the contention and remediate it, or you can proactively prepare your cluster so that you can totally avoid the contention. Right now, the existing DRS, the way it works is it reacts to the contention. So whenever contention happens, it moves the VMs in the cluster. So the benefits of this approach is minimal overhead because we only react when the contention happens. But the downside is there is a possibility that VMs may suffer briefly because the remediation happens after the contention starts. When it comes to the proactive approach, again there are two ways. Either we can statically reserve more resources, like I said, but this will result in wastage of resources. When it comes to performance impact, there won't be any impact because we already reserve a lot of resources here. The other approach is by learning or predicting the future demand. Can we predict the future demand and remediate or prepare the cluster so that we can totally avoid the contention? We can do that, but it will not have any performance impact. But the downside of this is we cannot predict all the workloads. There are always some workloads that are unpredictable. Also, if there are any occasional spikes or unexpected spike, this approach would not work. So what is the right way? What is the best solution to address this contention? It's actually a balance of both the approaches. We need to predict the future demands. At the same time, we need to react to the unexpected spikes. And this is what exactly predictive DRS is. Welcome everyone for the talk on predictive DRS performance and best practices. My name is Sai Inabatani. I work for DRS performance team. So during the course of this talk, we'll talk about introduction to predictive DRS or PDRS. So since this is a performance talk, at a very high level, I'll also talk about how it works. And then we'll talk about the software requirements and configuration. By the way, anyone here are actually using predictive DRS? Or tried? Oh, 1, 2, I can see 2 people, that's good. Okay, since this is relatively a very new feature, I'll also talk about the software requirements and the configuration so that it will help you to get started. And some application performance case studies. In this section, I'll talk about how enabling predictive DRS will help your applications perform better. And some frequently asked questions. Look, whenever I talk about PDRS, people ask me the same set of questions. So I thought it would be better if I can answer some of them here. These questions will also help you understand predictive DRS better. And some concluding thoughts and Q&A if you have time. Okay, so what is PDRS? PDRS is not entirely a different DRS. It's actually built on top of existing DRS. So we all know DRS does a very good job of balancing our clusters. Imagine the same DRS has given the ability to predict the future workloads and then recommend migrations. That's what predictive DRS is. It's a DRS enabled with predictions. So how is this DRS has got the ability to predict the future workload or future demands? So this ability to predict the workloads or predict the future requirements of the workload is coming from the VROps. It's the powerful resource scheduling of DRS together with the predictive capability that's coming from the VROps. So essentially vCenter, which is DRS, together with VROps makes PDRS. And like I already mentioned, it uses the balanced approach. It reacts to the workloads, at the same time it predicts the workload. So how does this work? Like I mentioned, I'll talk about at a very high level, like how the data flows between the vCenter and the VROps. So first, all the resource usage data of all your VMs is collected and then sent to the VROps. So this VROps has this powerful analytics engine inside it. It is comprised of multiple machine learning algorithms. So all these algorithms takes this data and then they generate predictions. So the predictions that are generated on the VROps are then sent to the vCenter or DRS to consume. So once the predictions are available on the vCenter, DRS consume those predictions and then it will generate recommendations. So what are these predictions that gets generated from the VROps? So if you have used VROps before, most of you are using VROps, right? Anyone? Yes? Okay. So if you have used VROps, you must be familiar with this term called dynamic thresholds. So these dynamic thresholds are actually fueled by the analytics engine which I referred earlier. So it has this sophisticated analytics engine. It is comprised of more than 10 different algorithms. So what these algorithms do is they take all the data from the vCenter and then they learn the normal behavior for each object and each metric inside for each object. It's not just the virtual machines, it's the host, data stores, and all the metrics for these objects. For all these metrics and all these objects, it learns the normal behavior first. Once it learned the normal behavior, then it starts to detect the patterns. It can be daily or monthly, it depends on the workload. Once the patterns are generated, it starts to generate the upper and the lower bounds, which are referred as dynamic thresholds. These upper and lower bounds of the normal behavior. For example, it predicts for the next 4 hours, the normal behavior could be somewhere around 60, so the upper bound could be somewhere between the 100 and 40, something like that. So these lower and upper bounds are referred as dynamic thresholds in the VROps. So once these dynamic thresholds or DTs, once these are available on the VROps, these are sent through a filtering logic where they are refined, polished to generate the predictions. So these predictions are then sent to the vCenter. Okay. So what is it takes to configure PDRS? So first let's look at the software requirements. I mentioned you need a vCenter and VROps. So for vCenter, you need a 6.5 with Enterprise Plus license. And for VROps, you need at least a 6.4 or a latest version. In case you're using 6.4, you have to note that there is a limit of 4,000 VMs, support limit of 4,000 VMs in a given cluster. But if you're using VROps 6.5 or above, there is no such limits on the VROps side. Whatever the scale your vCenter supports, VROps will handle that. So how many here are actually using vSphere with Enterprise Plus license? And of you guys, how many also have VROps? Okay, for all of you guys, PDRS is actually free. All you need to do is just enable it. Okay, so I want to show you actually how simple. I just said you need to enable PDRS because it's coming for free for you. So how do you configure it? How do you enable it? It's very, very simple. All you need to do is just enable a checkbox on the vCenter and enable a switch on the VROps. When it comes to enabling it on the vCenter, all you need to do is just enable this checkbox. You'll find this checkbox under cluster configure, just navigate through that, and then you'll find a checkbox saying enable predictive DRS. So once you enable this, whenever there are predictions available on your vCenter, DRS will use them. Yes, one thing you need to make sure is your vCenter server and the VROps, their clocks needs to be in sync. The reason for this is whenever VROps sends its predictions into the vCenter, it uses its own timestamp. So if the vCenter and the VROps are not in sync, vCenter cannot use those predictions. When I say both the clocks needs to be in sync, the time difference between the two servers has to be less than 5 minutes. If the clock skew is more than 5 minutes, vCenter cannot use those predictions, it will discard them. Configuring it on the VROps, again, it's a simple switch. So once you add your vCenter to the VROps, under the vCenter adapter, you see advanced settings tab. Under this advanced settings, you see a switch saying like provide data to vSphere predictive DRS. Just set it to true. So whenever predictions are available on the VROps will push those predictions back into the vCenter. Okay. So I mentioned in the beginning, PDRS is actually built on top of DRS. So when it comes to the performance of PDRS, it's no different from DRS because it's built on the same logic. then you must be wondering, what is the additional benefit that my applications get if I enable predictive DRS in my environment? So let's talk about that. So for this case study, we have chosen the follow the sun scenario. So follow the sun is a typical scenario where people or the VMs run in different time zones. So for this example, I have chosen three type of applications or three type of VMs. Each type is running in different time zone, and all of them are running on the same cluster. Here, the duration of each workload is 8 hours to pretend it's a 9 to 5 scenario. If you see here, at this point, the type B application starts. And at this point, type A application ends. So there is a brief duration where type A and type B run together on the same hardware. So they have to share the hardware. And if you look at the point of impact, at this point, when all the type B applications start, there will be a sudden increase in the resource usage or sudden increase in the resource requirement on the host. Because all the type B applications start at the same time. Because people in that time zone, all of them will come and log in at 9 o'clock in the morning. So at this point, there is a good chance that your cluster may go out of balance, and this could sometimes potentially result in resource contention as well. So let's take this point and see how enabling PDRS in this case will help the performance of both type A and type B. Because when contention happens, it will impact both type A and type B. So we have two cases here. The first one, how is that having PDRS or impact of predictions on type A workloads? And what is the impact of predictions on type B workloads? Like if you enable PDRS, how is that will help the type A workloads which are already running, and how is that will help type B workloads which are about to start? So for this, we have chosen the benchmark DVD store. For those of you not familiar with DVD store is an OLTP benchmark. It's primarily CPU intensive. So at the end of the benchmark run, it gives its throughput as transactions per minute. And the VMs we used are the Windows and DVD store ones. So DVD store ones are to measure the performance impact. Okay, let's look at the case 1. What is the impact on type A workloads? So I have an initial state like this. I have 4 hosts, and if you can see, all my 4 hosts are like almost equally utilized, and overall the cluster utilization is relatively low. When we look at the VM's distribution inside this host, if you see here on each host there are like these green boxes, the green rectangles. So each green block represents a VM, and the size of the block represents its workload. So in this case, you see there are multiple blocks, multiple bigger blocks, and there are multiple small blocks. So these small blocks are the type B VMs. They are idle right now. That's why you see the size of the block is like very low. So in this case, they represent type B because they are idle right now. They're about to start. And the ones that are already running, the bigger blocks, they represent type A because they're already running on the cluster. And in my case, these are the DVD store ones because I wanted to measure the performance impact inside type A. Okay, this is my environment on the vCenter. Let's look at the VROps. So VROps started to generate predictions for the type B VMs. So these VMs are idle right now, and if you see inside the green circle, there is a prediction chart. So this whole thing is a prediction chart from the VROps. So this is a prediction chart for one such Windows VMs. There are multiple of them running on my host. So if you see the dark line, the dark blue line represents the current usage, and inside the green circle you can see the gray portion, that is the predicted workload. And VROps has predicted for my VM, in a few minutes the workload is going to increase because these applications are about to start. So once VROps has these predictions, it then sends them back to the vCenter. Once the predictions are available on the vCenter, DRS started to generate recommendations. So in my case, I have 2 runs here. One is if PDRS is disabled, I don't have any predictions, so there are no recommendations. But if I enable PDRS, because there are predictions coming from the VROps, DRS used those predictions and it started to recommend migrations. If you remember the cluster state, the cluster is almost relatively underutilized. Most of the hosts are around 20% used. So there is no need for recommendations. But PDRS recommended the vMotions because it got the predictions from the VROps, and based on that, It wants to prepare the cluster so that it can handle the upcoming spike. Okay, let's see, and I apply those recommendations, whatever DRS recommended. And after I apply those recommendations, let's see what is the final state. Final state after the type B workload start. In PDRS disabled case, you can clearly see that one of my hosts is short of resources because all the VMs or applications have started on the same host. Now DRS has to intervene and it has to distribute the workloads. But with PDRS enabled case, you can see that since the DRS has proactively migrated the VMs, the application started on different hosts and there is no contention at all. And how this resource contention has actually translated into application performance. Let's see the DVD store throughput charts. Okay, here I have two runs, one without PDRS and one with PDRS. The green one represents where you see a small dip, that's a green one. The green one represents a run without PDRS. And the blue one, which is more consistent, that's the run with PDRS. So at this point, all the type B workloads start. Because of that, there is a contention on the host. So when I don't have PDRS enabled, you can see the application performance throughput has dropped. And at this point, DRS remediated whatever the imbalance. So it distributed the VMs. So there is a duration between these two arrows. Like in my case, it's around 3 minutes. For this 3 minutes, my application performance has taken a hit. This 3 minutes will depends on the environment to environment. In your case, if the contention is more, and DRS has to move a lot of VMs, this could be even more. Okay, let's look at the other case. So how is that enabling PDRS will also help the new applications that are about to start, which are type B. I have a similar initial state with the same set of 4 hosts. Again, my overall cluster utilization is very low. And if you look at the VMs distributions, again, I have few VMs which are already running, and I have a lot of VMs which are about to start. So this bigger blocks represents type A, because these are the ones that are already running. And in this case, they are the Windows VMs. And the smaller ones, which are idle right now, and they're going to start soon. So these are the DVD stores. And in this case, type B or the DVD store, because we wanted to measure the performance impact on type B applications. Okay, this is on the vCenter side. When we look at the VROP side, again, this is a prediction chart for one of the DVD store VM. You can see it's a DVD store prediction chart. And inside the circle, it again says the workload for this VM is going to start soon. So once these predictions are available on the VROPs, these are sent back to the vCenter. And on the vCenter side, DRS has started to consume these predictions. And if I enable PDRS, I can see there are a lot of migration recommendations, because DRS is asking me to balance the workload because of the predictions and from the VROPs. If I disable PDRS, I don't see any recommendations because there are no predictions. So I applied these predictions, whatever recommended by the DRS. Then what is the final state? If you look at the final state, again, in PDRS disabled case, because you can see like there are a lot of multiple small blocks on one of the hosts, and all of them started to ask for more resources. And you can see there is a clear contention on one of these hosts. In PDRS enabled case, since we proactively migrated the VMs even before the workload starts, there is no contention because and the overall workload is distributed. Okay, let's see how this contention is translated into application performance. When we look at the DVD store charts, again, I have 2 runs, the blue one and the green one. Blue one is without PDRS, and the green one is with PDRS. So you see green line is more consistent in terms of throughput, but blue line, it struggled initially because when all these type B applications start, there is a contention. So it took some time for these type B applications to hit the peak load. So this is where all my applications start. In the blue line case, if you see the throughput, it's around 3000 ops per minute. But the green one, if you see at the same point, it's more than 5000 ops. That's because there is a contention in the blue case, but there is no contention at all in the green case. And at this point, DRS remediated the imbalance, whatever it is. And in this case, it also took some time for my benchmark to stabilize to reach the peak load again. So overall, in this case, my benchmark has suffered for almost 4 to 5 minutes. And that was totally avoided when I enabled PDRS. Okay, so it's not just about load balancing, and there is additional perk that you get if you enable PDRS. So how many of you use DPM? None of you? Okay. Okay, so for those of you not very familiar with DPM, DPM is a power management engine. It's a cluster level power management engine. So what it does is it provides you additional power savings. So let me briefly talk about how it works. So what it does is it dynamically consolidates the workloads onto fewer hosts whenever there is a low resource utilization on the cluster. So it migrates the virtual machines onto fewer hosts, and whatever the unneeded ESX, it will power them off. It will put those hosts into standby mode. For example, I have 8 hosts, and all my applications can safely run on 6 hosts. So DPM will move all these VMs onto 6 hosts and put 2 hosts into standby mode so that I can save power. So that's how it works. And whenever there is an increase in demand, resource demand, these hosts are powered back. So this whole thing is done by the DPM. So I want to stress about this last point. So when workload demand increases, ESX hosts are powered back. So this is again a reactive approach, right? So it will power the host back after the workload demand increases. So it takes some time for the DPM to react, and then it takes some time for the host to power on, and then it takes some time to distribute the load. So overall, there is a good amount of time my workloads may suffer if there is a contention that happened because of the sudden increase. But what if DPM can use these predictions and it can proactively power on my host even before the workload demand increases? And that's what DPM does. So again, let me show you a simple example. I have 4 hosts, and all my VMs can run safely on 3 hosts. So DPM has put one of the hosts into standby mode. You can see all the applications are fine. All the hosts are like almost less than 40% utilized. So there is no real need for extra host now. But because of the predictions that are generated from the VROps, and these predictions are sent to the vCenter. So this is a prediction chart for one of the VMs running on one of these hosts. So because of these predictions, and you can see the prediction says the workload demand is going to increase in this case. So because of these predictions, when these predictions are sent to the vCenter, DPM has recommended to power on the host. If you look at the cluster distribution, cluster load, there is really no need for extra host. But in this case, purely because of the predictions, DPM has recommended to power on extra host because there will be an increase in demand soon. Okay, so let's look at some of the questions. So what workloads that PDRS can predict? Are there any applications that PDRS cannot predict, or are there any applications that are application load that PDRS can predict better? So the simple answer to this question is any type of workload with periodic usage pattern can be predicted. So when I say periodic usage, a periodic pattern, short spikes of the order of minute. For example, there are short 5-minute spikes. Those short spikes of minute order will not be predicted, and it makes sense, right? For example, if there is a short 5-minute spike, you don't want to predict that and recommend a migration based on these 5-minute spikes. Most of the time, this short 5-minute spike represents the unexpected increase in demand, like very occasional. So recommending a migration based on these short 5-minute spikes will not make sense. And more consistent your workload is, or more consistent your workload pattern is, more accurate the predictions will be. Learning period. So I said VROps takes all the resource usage data from the vCenter, and then it starts to learn the normal behavior, and then it generates the dynamic thresholds. Then those dynamic thresholds are polished to generate the predictions. So how long will it take for this whole process? So what is the amount of time that VROps takes to learn the normal behavior so that it starts generating the predictions? So that period is referred as learning period. So by default, this learning period is set to 14 days on the VROps. The reason for this 14 days is because based on these predictions, we are going to migrate the VMs. So just to make sure that whatever the predictions that gets generated are more accurate, by default it's set to 14 days. So once you add your vCenter to the VROps will need 14 days of resource usage data to start generating these predictions. And longer the learning period, obviously, the better the accuracy of predictions. If you have predictions after 14 days and you have predictions after 28 days, the predictions you get after 28 days will definitely be more accurate than the ones that you get after 14 days. And these predictions will be available only after 14 days of data. So if you just added your vCenter to VROps like 2 days ago and you don't see predictions, that's because there's not enough data. Okay, the current demand versus future demand. So how is it PDRS gives the weightage for the current requirement and the future requirement? For example, my VM's current requirement is 90% of CPU and its future requirement is only 50%. So what is the weightage given to current requirement and the future requirement? How will PDRS handle these scenarios? So the answer is PDRS will always ensure your current VM requirement will not be affected to favor the future requirement. So in this case, if your current requirement is 90% and your future requirement is 50%, PDRS will consider your VM requirement is still 90%. So the bottom line here is the VM demand, the way it computes the VM demand is it's always the maximum of current requirement and the future requirement. So it will always ensure your current demand will never be clipped to favor the future demand. So this will ensure your current VM performance will not be affected at all because of the predictions. So it takes the conservative approach. Tuning. So I mentioned in the beginning it's very easy to configure PDRS, just a checkbox and a switch. So people always ask me, are there any knobs or parameters that I can use so that I can tune PDRS for my specific use case? So here I have listed two knobs, one on the VROps and one on the VROps side and one on the vCenter side. I mentioned this dynamic threshold are generated like after 14 days of data. So this 14 days of data, and these are generated actually once in a day. Every day morning at 6 o'clock, once it has the 14 days of data, every day morning 6 o'clock, these DTs are generated. So in case if you want to force VROps to manually generate these DTs, you can use this dynamic threshold button, and you can see it under the administration support section. There is a DT option. You can use this button to force the VROps to generate the DTs. And look ahead interval, this is on the vCenter side. So look ahead interval is the amount of time DRS looks ahead while accounting the predictions. So whenever DRS runs, it checks what is the current requirement for this VM and what is the requirement in the next 1 hour. So this next 1 hour is the look ahead interval. So by default, it's set to 1 hour. You can change this to up to 12 hours using a DRS advanced option. Okay, so VMs with predictions versus VMs without predictions. So I said VMs need at least 14 days of data so that they can have predictions. So what happens if you have some newly powered on VMs in the cluster? For example, you have 150 VMs in your cluster and 100 VMs are running for 30 days and 50 VMs are recently powered on like 2 days ago. So what happens in that case? Because the 100 VMs will have predictions, because the 50 VMs which are recently powered on, they do not have predictions. So how will PDRS handle scenarios like this? It's pretty simple and straightforward. Like I said, for VMs with prediction, it's always the VM requirement or the VM demand is always the maximum of current and the future demand. If your VMs do not have predictions, the VM demand is simply the current demand. Filtering predictions. So VROps sends these predictions once a day, and once a day it sends the predictions for the next 26 hours. So for these 26 hours, it will send 52 samples, which means like one sample for every 30 minutes. So it sends all these 52 samples once a day. In one go, it will send all the 52 samples to the VC. So if in each of these 30-minute sample that VROps sends to the VC, each of these sample will go through a filtering logic where VROps has this own accuracy criteria. So if any sample that does not meet the accuracy criteria will be discarded and it will not be sent to the vCenter. So if you're wondering if you have VMs that are unpredictable, whose workloads are unpredictable, and they run alongside with the normal VMs, how will VROps handle these cases? No problems. VROps still has this filtering criteria inside it. So if any predictions are not accurate, VROps will not send them to the vCenter. And if there are any consecutive samples that are similar, for example, morning 10 o'clock to 12 o'clock, the workload prediction is the same. So it will merge these individual 30-minute samples into a single multi-hour sample, and then it will send only one sample. Okay, so this is one of the most often asked questions, like how to identify vMotions that happen due to predictions. How can I differentiate if the vMotion that happened is because of prediction and the vMotion that happened is not because of prediction? So actually there is no straight answer to this. Let me explain you with an example. Let's say I have two hosts, A and B. In this case, I have three categories of VMs. The red ones do not have predictions, and the green ones have predictions. The blue ones have predictions, but they are dropped. When I say dropped, their future requirement is less than the current requirement. So it always considers the maximum of current and the future requirement. So for these blue ones, the predictions are dropped. So in this case, there is an increase in resource demand on host A. That is because the red ones and the blue ones are started asking for more resources. So because of this, there is an increase in demand on host A. So now DRS has to intervene. So it moved blue VMs out of this host A to host B. The reason why it chose the blue ones is because moving the blue VMs will balance the cluster faster. As simple as that. Now, why are these blue VMs moved? Is it because of predictions or not because of predictions? If you look closely, blue VMs are actually moved because there is an increase in demand on host A. And that increase in demand has actually contributed by the green ones and the red ones. Green ones have predictions, but the red ones do not have predictions. In this case, we cannot clearly differentiate the blue ones are moved because of predictions or not because of predictions. But there are also other cases. For example, if your cluster has only the green ones, like all of the VMs have predictions. In that case, you can actually differentiate the predictions, but unfortunately, you cannot do that through the UI right now. You can do it only through the logs. Hopefully, in the future, you might see that in the UI itself. Okay, so let me conclude with these 4 thoughts. PDRS can help avoid the contention even before your application performance drops. And it does it because it proactively prepares your cluster so that your cluster can handle whatever the spike that's going to happen. So forecasting in PDRS works best for VMs with periodic usage, like 9 to 5 scenarios. And current demand of your VM will never ever be clipped to favor the future demand. So this will always ensure your current VM performance will not be affected at all. And lastly, it provides the best solution by using a balanced approach of using both reactive and proactive methods to address the contention. Okay, so we have a few links. These are not directly related to PDRS, but this will give you more insight into DRS and its activity. Feel free to explore them. So we have 2 links, DRS Lens and Dump Insight. So this DRS Lens is a simple dashboard. So it will provide you an insight into DRS activity and all. And the other tool is Dump Insight, where you can provide upload DRS logs. So this is a service portal. You can upload DRS logs and you can see what happened during the DRS run. So it will give you how many recommendations were, how many VMs were moved, and the reason why they are moved, and how many were dropped during cost-benefit analysis. You get a lot of clear information. You can just explore them. And there are some other performance sessions. If anyone is interested, please do attend. And thank you. Okay, if you have questions, please feel free to ask. We have time. Yeah.
If you change the resources of a VM that has predictions, what does that do to the prediction?
Sorry, I cannot hear. Can you?
change resources, compute on a VM that has predictions?
Resources in the sense, like you meant.
Memory, CPU. What does that do to its predictions for that VM?
It will not impact. So the predictions are actually based on your VM resource usage. So you meant reconfiguring a VM, right? So reconfigure a VM if it does, as long as it does not affect the resource demand or resource usage, it will not have any impact on the predictions.
I've got a question. For those of us who've been using VROPs for a while and have VMs with established dynamic thresholds, does it take those into account or does it start fresh when you enable this?
Can you be a little louder? Or?
For those of us who already use VROPs but don't have this enabled, and they already have established dynamic thresholds.
Yes.
When you enable this, does it take those into account or does it start fresh?
Yes, it does take into account. So all it needs is the data to be available on the VROP side. So in your case, your VROPs has already all the data available, so it will just take the data into account and it will start generating the predictions.
Do you need your host to be at 6.5 or just your vCenter?
It needs to be in 6.5.
So the host.
Host, yes.
How does Predictive DPM handle host boot times?
Right now, it will not consider the host boot time, actually.
Okay,
Yeah.
Just because we've got blades that take 20, 30 minutes, sometimes to boot that are just
Yeah. No, it does not consider that right now. It's from the management perspective. Yeah. Yes.
Hey, if you've got DRS rules in place, affinity, anti-affinity, whatever, and VROPS detects that one of your VMs is coming up with predictive DRS,
yes,
but it can't move that VM. Will it move the other VMs on that host to free up enough resources?
Yes, it does account
spike?
all the rules. So, like I said, it's not a different DRS.
No.
So it's PDRS will only provide you the predictions.
Yeah.
So whenever DRS runs, it just accounts these predictions, and since DRS already accounts whatever the rules that you have set in the cluster, it will honor them.
Yeah. So if a prediction comes through for a VM that DRS can't move because of a rule, will it move other VMs?
No, it will not. So the priority is your rule first. Yeah,
Sure.
it will honor the rules. Yeah, it will not move them because of rules. Yeah.
Yep. Cool.
Yes. Yeah.
So how regular if I have a 1 hour process that varies the start time by about an hour every day, how regular does that have to be? Will it know that at some point within this hour I'm going to start a process, or does it have to be more specific to a start time than that?
You meant the workload, VM workload, how regular it has to be? It doesn't have to be regular. I mean, it all depends on the data. For example, Monday morning it starts at some time, and Tuesday it starts at some time, and in the end, if there is a pattern overall, like every Tuesday it starts at 10 o'clock, every Monday it starts at 8 o'clock, for example. So
okay.
That kind of patterns will be predicted.
We have a workload we have a process based on workload from day to day, which could vary anywhere from a 7 a.m. start time to an 8 a.m. start time. Is that too much of a variance for it to see?
No,
That's good?
Yeah.
Cool.
Good talk, Sai.
Hey, thanks, Rasa.
So you in your examples, you only looked at CPU usage.
Yes.
How about other resources?
Yeah, it will still consider. I've just taken one example because this benchmark, whatever I used, is CPU intensive.
Right.
So I've just shown.
So it applies to memory.
Yes, it applies to memory as well. Yeah.
About storage DRS?
No, storage DRS. That's different. Yeah.
So if I'm using the view adapter inside of VROPs, will it also predict all of the VDI? Right, so if we have the adapter inside of the VROPs to look at all of the view sessions or anything that's instant clone or link clone, will it predict
it's only looks at the data that is coming from the vCenter.
Okay.
So yeah, whatever the view adapter you have, right now it's not
so right now
taken into account.
Okay.
Yeah.